this talk is more about features of the language and how those features enable us to solve problems that either are not solvable at all in Java, or they are solvable, but with a few caveats that are nasty. Before we start, I don't have a slide with all my details, but I've been playing with computers, basically working with them since 2001. Did IT, networking, programming, everything. And I've been working with Scala since a couple of years ago because I got bored of Java. 10 years is too long, or 12. I don't know. I don't want to remember. So yeah, I'm also a contractor. So wherever I'm now, I'm not going to be there next year. But yeah, today we are going to talk about polymorphism and how some functional concepts, which are the type classes, help us to do ad hoc polymorphism in a better way. So basically, yeah, I'm also a backend developer, so the slides, they don't look nice. Sorry. It is what it is. Tried to get hold of my wife to fix that, but I wasn't successful. So, polymorphism. Does anyone need an explanation of what's that? Good. So basically, we have different types. We use the same message to communicate to these different types, and we don't get odd behavior, we don't get failures. We get different behavior based on the types, but that's expected because otherwise we wouldn't have different types. But the idea is we can treat different unrelated stuff in a similar way. Of them, there are three types. The first one is ad hoc. And ad hoc means that the polymorphism is going to happen based on who I am. So basically, if actually no, who the parameter I'm calling my collaborator with is. So if I have a library that sorts lists or arrays, whatever, if I'm passing an integer, then this method is going to be picked by the compiler, by the random actually. And if I'm passing a list of strings, this one is going to be picked. I didn't use a list on purpose because type erasure, that wouldn't work with overloading. But basically, what wasn't? Can anyone spot a problem with something like this? Yeah.
Polymorphism has to use dynamic dispatch, and that's statically dispatched because it's overloaded.
Yes, there is another problem. Let's position ourselves on the shoes of somebody that is building an API that is going to be used by random people that you don't know, right? So the problem here is that my library is very, very good. It sorts integer, it sorts strings. If I give them a collection of doubles, that doesn't work. It's not going to compile. So what it has is that it's nice because I have a bunch of methods. They are already made. The user can call them. They sort the list. Boom, it works. Now, if the user has a different type that he wants to use my library with, then my library is useless for him. So it's lacking on flexibility. So then, different type of polymorphism is using subtyping. So basically, I have a common interface or an abstract class, but whatever you pick. And different objects will implement that interface, and they will behave however they need based on the type. And so if I call the method defining an interface implemented by object type A, it's going to do something. If I do it with type B, it's going to do something else. And the example of that is a comparator, because the whole talk is about sorting stuff. By the way, is somebody here not familiar with the streams API on Java 8? Good. So yeah, we have a comparator, and we have int and string comparators, and they get objects because that's what the interface gets. So the problem here with subtyping is that we need to pick generic enough types, and it doesn't really look nice because we will have to cast in here or check if they are ints and then do something. And the other problem, this the good thing is it is extensible, right? We say our library works with comparators, and so the user can implement their own comparators, and everyone is happy. Now the problem is the types we have to use in the parameters, they are not overloaded like in the previous definition, so we need to be the user needs to be careful and cast, and it's not really nice. Which leads us to the third type, which is parametric, which is basically generics. So if we look at the same example again, and we have generics, then we can implement the comparators, and they are type safe, because this is going to be checked at compile time that you are not doing something fancy, and if you get here something, it's going to be an integer. Now, the pro with this is that it's extensible with the user, it can work with any type, and it looks more type safe, and I don't have that nasty casting stuff. It's better. Now, the problem is that it's harder for my library to provide us a pre-made set of working things, because yeah, I can ship a bunch of comparators, but then the user needs to know that they exist, and it needs to know where to find them, and it's not as easy as calling a method and then the dispatch will figure out based on my type. So can we have both? Yes, we can, and Java has an attempt of that since Java 1.8. So basically, in Java, if we have these two lists of same elements with different types, so the example is easier. If I try to print a sorted version of those, basically we get a stream, we sort it, and then we collect it to a list. And does that work? Anyone? Come on. Okay. I've been teaching at uni for 5 years, so I try to get the people, you know. So yeah, it works. Of course, it's simple enough for the JDK to support that. Now, let's introduce this nice wrapper thingy that basically wraps an integer and does something not very important, but it's a custom type, right? So good this list, which again, it has the exact same order as the previous ones. If we have this list, good this work, what is going to happen? First of all, why it doesn't work?
Private field access, and if they implement a comparator, they can't access the field.
Isn't it just going to print out object?
It's going to have a nice class cast exception, because it's going to tell me, yeah, I tried to sort this, but it's not comparable. So, but the problem is that happens in runtime. So, of course, we should be writing tests for everything and stuff, but it would be nice if the compiler would prevent us of being stupid and don't do this. So, there is a way to solve this? Yes, there is. We can, yeah, I forgot about this. Yeah, I mean, to me, after working in Scala, this is a big what the fuck. I mean, how can I write some code and then just magically fails because I didn't provide a type? It's just mental. Now, do we understand? I mean, why the compiler doesn't warn us about this? Why the API is so crap? Now, the problem is that if we could solve this by always asking for a comparator here, right? That will solve the problem because everything sorted would be comparable. But then for most of the cases where we have int or standard types, we will have to provide comparators, and that would be crap. Or we could say, oh, you know what? You are not going to be able to beat the list if it's not comparable, so all the sorting will work. That's also crap, because most of the times we don't want to sort a list, so the list is not generic anymore. So we don't have a nice way to say, hey, how do we make this simple for the standard cases, like the simple values and stuff, and powerful enough so the user can provide their own way of sorting. So what Java does is like hope for the best, and and basically otherwise it will fail, and then you will say, yeah, fine, I'm going to give you a comparator, which is this nice lambda we put here. And if we do that, yes, we will get the thing sorted. But do you agree with me that that's kind of crap? Right? Even if you love Java, that's kind of crap. Yeah, I forgot to put the parental advisor as in the first slide. I tend to swear. Sorry. So yeah, we want the compiler to be our friend. The compiler can do a lot of job, and the good thing about the compiler doing stuff is that we don't have to write tests for that. So the amount of unit tests decreases because there is a lot of information encapsulated in the types, which means our code it explains by itself a bit more, and it's also safer, and it's easier to maintain, because having tests is nice, but when you have a lot of tests, even a simple refactor can force you to fix all the tests, which you should do, but I'm not saying, I mean, I'm super pro testing, but if I can delegate some of them in the compiler, then yeah, that's why I hate JavaScript. Because I have to write many more tests. So Scala, how type classes, I have to speak to this thing, how type classes help us. Okay, we have the same two lists in Scala. Notice also the nice syntax, all type inference. This is 2010 model, throw away all the other shit. And also, there is no stream, no collect, no bullshit, right? We say in.sorted, boom. That works, of course. Yay. And it's print as a list, not as an array with the brackets. I don't know what they were thinking when they did the toString of a list. So remember our friend. By the previous presentation, we already know about what is a case class, but just to remind you, so beautiful. And so let's say we have, what the fuck? We have a list of those wrappers. Again, notice the nice syntax, no news, no nothing. It's quite nice. It's still verbose, but that's the name of the type. Hey, what can I do? Question: does that work?
All the compile time. Sorry, a bit of compile time, isn't it?
Does it work? Does it compile? Well, I've been saying compiler many times already, so if you think yes, you haven't been paying attention. No. We get a nice error at compile time. So basically, it's telling us, forget about this, ordering is not there for a wrapper. Sorry, we don't have enough arguments to method sort. But what arguments? I'm not passing any arguments to this. So how come the error is saying that we need some arguments? Okay, let's look at the definition, at the signature of that method. What? Okay, yeah. I may miss a little spell. Anyway, okay. We can sort this in the same way we sorted with Java, right? We create an ordering, which is basically the Scala version of comparator. And we say, yeah, given an xy, we compare, blah, blah, blah. And we pass it to sorted. Notice that now, somehow, it has a parameter. And then if we execute this, it works. Now, this thing, the first time you see it, is like, how come the same method can have parameters, and then, but the last time we tried to use it, it doesn't? And how come the compiler knows that now it's fine, but before it didn't, and then, but for an integer, it didn't ask for anything? So this is the signature of the sorted method in any Scala collection. So simplify a little bit, but you get the idea. So to sort something of type B, we will return another list of type B. And then we have this. This is, by the way, this is the only definition of the method sort. It's not that we have a method with the parameter and a method without the parameter. The method always have the parameter. The thing is, the magic is in this keyword. It's an implicit parameter. What that does mean? I mean, if you remember the error, it says no implicit ordering defined for wording for wrapper. So what is this implicit? This implicit is a keyword that will tell the compiler to say, hey, if you find some implicit variable value, we don't like variables, of this type, and with this type, it's not just this type, is the whole thing is a type in Scala. So it has to be an ordering of type B, which is the type we are trying to sort. So basically, if you find something in scope of that type, the compiler will automatically complete the method invocation by passing that ordering instance to the sorting method. So in Scala, when we wrote the sorting for an integer or for a string, it's not that it's working like in Java under the hood trying to figure out if it is a comparable or not. The compiler, for us, stick an ordering of type string or type int automatically because it knows about those. And we will get on how it does that. But let's see how this would work in a very simple example. If the same ordering we defined before as a standard val, if we now define it as an implicit val, then we can leave the parameter out in here, and if we run this, not shift, it's going to work. So basically what is happening for an int is that this thing is coming from somewhere else, but it's there. And that's why the compiler can check it. And that's the thing that you cannot do in Java. You cannot rely on the compiler to complete your method.
I'm sorry.
Yeah.
Would it be fair to ask that from Java, given the fact that you can actually reassign the variable to something that might implement comparable?
Well, sorry.
Would it be fair to expect that in Java as well, given the fact that you can reassign the variable of that type to something?
You can't, because when the variable is of list of some type, and you cannot reassign
Yes.
with a list of a different type.
Yes, but you can pass objects that over subtype of that type that actually implements comparable.
But you could do the same in Scala. The thing is,
Yes.
is this trick of that the compiler can be more restrictive, because with the implicit parameter it knows the type is trying to work on, and then it can always request, it can always expect to have a comparator. In Java, the problem is we cannot always expect to have a comparator, so we rely on whatever is in the collection being comparable.
Yes, but in Scala,
Yeah.
you infer the type of that value, right?
Yes.
Given by the value.
Yes.
So you infer the minimum type.
Yes.
The minimum type, right?
Yes.
And you know whether that type is going to implement comparable or not. But in Java, you say this type, you say the list is of, you pass in generics this type.
Uh-huh.
But really, the objects that you can pass inside can actually implement comparable.
You mean
I
a
don't
type
understand the
that
question.
extends
Yes.
The base.
Yeah. Yes, and implement
The base
comparable.
interface.
Yes.
So you can have like a only for some of the subtypes
You can
Yeah.
implement
So,
comparable.
I mean, yeah. So basically the issue would only...
But you're still playing with file, no?
But the thing is, if you're trying to sort something that you don't have control over it, and that's not comparable, it will fail.
What if it is?
Yeah, but that is the problem. What if you're going only to find it in runtime?
That's the difference between Scala and Java, right?
Not really. The typing in that sense is equally restrictive in both.
Yes, but in Scala you are going to infer and you are going to infer the minimum type, right?
No, you have to infer the exact type. I don't think that type classes works with inheritance. I haven't played with that.
I think they...
Well, it depends.
Yeah, it depends on the covariancy and everything.
No, but I'm not talking about that.
Okay.
I think it sounds like a perfect pizza and beer.
Yes. Can I take that for later? So yeah, we have our nice case class. So basically, we say that the compiler has magic ways to find the ordering, and that magic way is the implicit. Now, the implicit lookup has several steps that I don't remember by memory, but basically, it's going to try to search first from the most particular to the most general. So if you have an implicit val, like we just did in the previous slide, because that's defined right there, the compiler will just pick that and forget about anything else. If it doesn't find something in the closed scope, it's going to look at if we are inheriting some implicit val of that type, or if we are importing some implicit val or def of that type. And if it doesn't, it's going to be nice, and it's going to be look at the companion objects. The companion objects in Scala are basically, so Scala is pure object-oriented, not like Java. So static doesn't exist, because that's not object-oriented. So what you have in Scala is the companion object. An object is a singleton, basically, and a companion object is a singleton that has the exact same name of the type, and so they basically work together. So because it's a singleton and is related to the type, whatever you put there is only created once and is accessible even if it is private by the class. So it's more or less like having a static, but in a pure object-oriented way. So what the compiler is going to do is say, okay, for this type wrapper, if we go to the companion object and define the ordering in here, that means that after we do that, we can just ask for the wrappers to be sorted, and it's going to work without us having to define an ordering for it. So basically, if we have a class that we sort in a bunch of places in our system, and we know that we want to just have that definition once, we put that in the companion object, and suddenly our class is sortable, even without having to touch its signature. We don't have to go on. In Java, you would have to say, okay, my class is comparable, and I'm going to implement the compare to. Here, we keep it as a separate concern, and we say, yeah, my class provides a comparator, an ordering, and the compiler knows how to pick it up without me having to be like teaching it like a kid, which is good. Now, this is good from the user point of view. Now, from the API developer point of view, we have another thing. So the compiler will look in both companion objects. First, in the companion object of the class we are trying to sort, right? The type constructor, the type parameter, sorry, and then, but I don't remember the order, but it's going to look in both. So it's going to look in the companion object, in this case of int, to see if there is a comparator, and it's also going to look on the companion object of ordering. This is actually a simplified view of the companion object of ordering provided by the Scala library. So basically, the Scala out of the box defines different orderings for the common types. So that's why when we just type list of 1, 2, 3, whatever, and then we do sorted, it works, because the compiler starts looking in the implicit scope, and when it reaches to the top, it's like, okay, is it in int? Nope. It is in ordering? Yeah. Boom. There you go. And it completes the invocation to that method with that particular parameter. So then that's where we get the best of both worlds. We can do ad hoc, like we provide methods with some implementations for different types, and at the same time, the user can extend that and provide new implementations, in this case of ordering or whatever is our type class, to extend the polymorphism to types that are defined on their side of the world, on their whatever. So yeah, yes, 5 minutes. Yes, good. Hey. Yes.
So which companion objects does the Scala compiler look for? I was a bit confused. So let's say I had a list of ints.
Yes.
How would the Scala compiler know, for example, to look in the ordering type class? It can't check does it check every type class available?
No, it checks. I don't remember which one it looks at first, but it's gonna check. So in the int, let me go back. So at the type class, the definition of the type class is a class plus a type constructor, a type parameter, right? And the whole thing is a type. So it's gonna look only in these two types. Okay. Again, I don't remember the order, but whatever the order is, if the thing is there, it's gonna pick that one. Otherwise, it's gonna bubble up and go to the other one. So yeah, and then if it exhausts all the possibilities, then you get that compiler always for wrapper. Yeah.
So, assuming you have a list of wrappers.
Yes.
And the actual objects inside of this are all the subtype of wrapper.
Uh-huh.
Wrapper has its own comparator.
Yes.
And the subtype has another comparator. Which one is it going to use?
I don't know.
Okay.
It's fine.
I think the ordering is strict, right? It's not a variant.
Yeah, that's what I'm thinking. Because if
so it's going to ask for the exact type. So
yeah,
if you have an ordering of
yeah.
of an extending type, then that's not going to work.
Yeah, that's what I'm thinking.
Equality, the equal surplus is controversial.
Yeah, that's
Okay. That's it? Okay. Any more questions? We go to the pub. Yeah, that's where you can find a presentation if you like it or you care or whatever. And LinkedIn stuff. Thank you.